Hi, this is Mr. Knowles, and this instructional video focuses on the lattice multiplication method, which is a really interesting method to multiply numbers. It's one I learned about at the beginning of my teaching career, and I noticed that a lot of students really enjoyed learning this method and found great value in it with learning how to multiply large numbers. So that's one that I like to introduce to my students as an additional way to multiply. A lot of adults and parents sometimes are confused with this method at first because it's not the same one that they grew up learning. And to many people, they might say, "Well, what's this new math that you're teaching my student or my child?" And I find it interesting that this isn't new at all. It's actually very old. Lattice multiplication, which is also known as sieve multiplication or Jalosia method, dates back to the 10th century in India, and it was introduced into Europe by Fibonacci in the 14th century. It's an algorithm that's very similar to the traditional multiplication method that we typically learned here in the United States or in the in the West. But it breaks down the process into smaller steps. And I'm going to show you some examples, and hopefully you can catch on. So if you're a student watching this at home, I'd have your parents watch with you so you guys can learn together. And there are other sources on the internet that you could Google, like Khan Academy for one, would have this, as well as some other people. Let's get started. So I have the problem 22 times 13. And to solve this, we need a lattice, which is this box of four squares with triangles in it, and that's the structure, the framework that helps us solve the problem. So I'm going to set this up. I'm going to put a 22 here and a 13 here. And basically, this column here, there's columns here, there's two columns, and each column is below one of the digits in the number 22. So this 2 has a column before it, below it, I mean, and this 2 in the tens place has a column below it. And then the number 13 is on this side. It's always important to set up this way. And the 1 is part of this row. And then the number 3 in the 13 is part of this row. And that's important that you have it set up like that. What's going to happen is in this box, for example, we're going to solve the problem of 2 times 1. And you'll notice there's two triangles in there. Well, what's really going on is this is the tens place of that little multiplication problem, and this is the ones place of that multiplication problem, that piece, that 2 times 1 piece. So I'll get rid of those real quick. And 2 times 1, well, that's hopefully you know that one, that's 2. So you write a 0 in the tens place because there's nothing in the tens place for the answer of 2, and 2 goes there. Well, now we're going to go down to this problem down here that I just highlighted. And we're going to solve 2 times 3. Well, 2 times 3, that's 6. That would look like that. Let's see if I can use a different color. Maybe green. Now we're going to work on this number 2. The other one's all done. So we're going to work on this box right here. And we're going to do 2 times 1 in that box. 2 times 1, well, that's 2. And then we're going to work on 2 times 3 right here. And we're going to put it in that box right there, kind of like coordinates where they meet. 2 times 3, well, that's 6. All right, I'm going to do a little erasing real quick, just so we don't have any confusion with all this highlighting business. I don't know if the highlighting's helpful or more confusing. Okay, now we just got to do the adding part. That's where these diagonal lines come in. That's for the adding part of this. Each diagonal row is really place value row. For example, this 6 is really in a ones place. And then this diagonal row is really the tens place. This diagonal row is the hundreds place. And then I bet you could guess what that diagonal row is. That's the thousands place. I'm going to run out of room, so let's put some dots. And what I need to do now is just add them. Well, down here, there's nothing to add, it's just 6. So I'm just going to write it down here. Now I'm going to go to this tens place and I have a 2, I have a 0, and I have a 6. Well, 6 plus 0 plus 2, that's 8. Now I'm going to go to the hundreds place. There's a 0, there's a 2, and there's another 0. Well, that's just 2. Now I'm going to go to this place, the thousands. There's just a 0 there. I'm not going to put anything there. So my answer is right here, 286. Let's try another one. 15 times 41. So I'm going to set it up. And now I'm just going to try to solve those problems. And remember that 5 times 4 is going to go right in this box. Well, that's 20. And then 5 times 1 is going to go right here. And we know that's 5. Now I'm going to go over to the next column. And this is going to be 1 times 4 is going to go here. Well, that's 4. And then 1 times 1 goes in this last one. Well, that's just 1. And now I have these diagonal rows here, right? And I'm going to add those. So I have a 5 here. I just have a 1 here. 4, 2, and 0. That's 6. And then there's a 0. That's it. So my answer is 615. Let's try another one. 30 times 51. 30 times 51. So 0 times 5, well, that's 0. And 0 times 1, well, that's 0. That was easy. Go to the next column where the 3 is. 3 times 5 is 15. And 3 times 1 is 3. Okay, done. That was pretty fast. Now I got these diagonal rows that I'm going to add. 0. 3 plus 2 zeros, that's just 3. There's just a 5 in there. And there is a 1 in my thousands place this time. So the answer to this is 1,530. And I just put a comma there and I'm done. One last one. This one's a little bigger. 656 times 21. 656 times 21. So I'm going to set it up. I'm going to just start solving my problems. 6 times 2 is 12. 6 times 1 is 6. Now I'm going to go to the 5. 5 times 2 is 10. 5 times 1 is 5. Go to the next column. 6 times 2 is 12. 6 times 1 is 6. Okay. Now I'm going to draw these in so you can see the adding part. That's sometimes a confusing part, I think, for some people. And add away. 6, 2, 0, 5 is 7, 1, and 6 is 7, 1 and 2, 0, 3, and I got a 1 there. So my answer, I'll just write it down below. This is equal to 1, 3, 7, 7, 6. Put my comma in the correct location, 13,776. Well, I hope this has been helpful to you. If not, definitely check out Khan Academy's lattice multiplication videos, and I'm sure there's many, many more, or just ask me some questions. Once you get the hang of it, I think you're going to like it.